Welcome to today's daily video lesson. Today's topic is manipulating mathematical expressions. As with all daily video lessons, feel free to pause the video and try the problem on your own before seeing the solution. In this case, we have two fractions, so we want to get a common denominator to combine them. Notice that if we multiply the first fraction by 2 on the top and the bottom, we will get a common denominator of 6x squared. Thus we have 4 over 6x squared minus 1 over 6x squared, and combining gives 3 over 6x squared. Notice that we can cancel 3 from the top and the bottom to get 1 over 2x squared. We want to break this down with exponent rules so that we don't make a mistake. We have minus 1 to the 2/3 power times 4 to the 2/3 power times x cubed to the 2/3 power. The 2/3 power applies to all of the terms in parentheses because they are multiplied together. This would not be the case if they had been added to each other. We see that minus 1 squared is positive 1, so we have 1 to the 1/3 power. But the cube root of 1 is just 1, which means that this entire expression is just multiplying the rest of this by 1 and has no effect. 4 squared is 16, and 16 to the 1/3 power is the cube root of 16. When we have a power raised to a power, as we do with x cubed raised to the 2/3 power, we multiply the powers together. 3 times 2/3 is just 2. So we have x squared. Notice that the cube root of 16 can be simplified because 16 can be broken down into 8 times 2, and 8 is a perfect cube. The cube root of 8 times the cube root of 2 times x squared, where the cube root of 8 is 2. Thus we have 2 times the cube root of 2 times x squared. The answer is presented in a different order, but multiplication is associative and commutative. In this instance, we only need to make one computation. Observe that we have 3x to the 4th and 4x to the 4th. When added together, that gives 7x to the 4th. Option D is the only option that has 7x to the 4th. In this problem, we want to multiply the functions f and g together, and then set it equal to the given polynomial. F is x squared plus bx, and g is 3x squared minus 9x. Distributing this out, we have x squared times 3x squared is 3x to the 4th. X squared times minus 9x gives minus 9x cubed. Bx times 3x squared is 3bx cubed. And bx times minus 9x is minus 9bx squared. We know that this, when simplified, we can combine the x cubed terms to get 3x fourth plus 3b minus 9 times x cubed minus 9bx squared. This is equal to 3x to the 4th minus 8x cubed minus 3x squared. Let's take the easier coefficient and deal with x squared. Since these coefficients must be the same because the equation is true, we have that minus 9b has to be the same coefficient as minus 3, because both are the coefficient of the x squared term. dividing both sides by -9 yields 1/3. Even if you were to choose to use the coefficient for x cubed, you would reach the same conclusion, because 3b minus 9 is equal to -8. Adding 9 to both sides gives 3b is equal to 1, and again, we end up with b is equal to 1/3. In this case, we want to make sure we associate the correct number with the correct currency. We have pfennigs and Groschen, which are worth 10 pfennigs each. Since we're using P for the smaller currency and G for the Groschen, we have P plus 10 for G, combining to make 85.